So for this one, I'm not sure how you got that, since neither of those have a y-intercept of -3. Um, you have this solution here of 1, -3, but it's like you're graphing this as 1 and that's -3, and that's not the same thing as this point. You should probably go back and spend some more time in section 3.3 where we did graphing equations of lines. The point 1, -3 is this point right here when x is 1, y is -3. So that's where these two lines should be intersecting. This next part that I'll do, let me make this a little bit bigger, all comes out of section 3.3 where we graphed using slope and intercept. So that would be the place to go back and review for the rest of this assignment. And likewise, intercepts I think are going to be on the next one. So this one, there's no number here, so that means this would be like -3x plus 0. So if we're in y equals mx plus b, that means the y-intercept is 0, so that would be right there, and it has a slope of -3, which means it's going to run 1 and drop -3. So that's the equation of your first line. The second line is the y-intercept would be -6, which is right here, and it has a slope of +3, so that means it's going to go over 1 and go up 1, 2, 3, and there's your intersection point at 1, -3. So again, graphing using slope and intercept seems to be what you're missing in terms of this concept. Your other option would be to make a table and then plug in points. So like for this first equation, if x is 0, y is -3. Excuse me, if x is 0, y is 0, pardon, right here. If x is 1, then -3 times 1, y would be -3, which is right here. And again, that's in the last chapter. That said, graphing using slope and intercept is definitely the easiest way to do that. So I would go back and